Thank you, Albert. Thank you, Tatiana, for the invitation. Gives me a pleasure to be presenting today to your group. As I was telling you, I was looking at the website, and I've been watching your work for quite some time, and I'm really impressed by the work you do at the Institute. So I wanted to congratulate you and to salute your work. So keep the good work up. I hope that in my presentation we will learn something today. I don't want to set high expectations, but I would love to share with you this experience that came to a fruition with two papers. One is already published, and another paper is still under review. So I'm combining, because this is one story actually that is divided into two kind of chapters. So let me walk you through this story, and then we'll see what we learn from that. Basically, this work is in collaboration with a former colleague of mine. We worked together at the American University of Beirut up until 2018, before I joined AUBG here in Bulgaria. So Neil York-Smith now is at Delft University in the Netherlands, and this work is in collaboration with Neil. All right, so what we do in this project, I will explain to you the context, but basically we use agent-based model. We also make a good use of GIS and GPS data to collect data at the micro level, and I will show you how important this was to our research. We also built on rent gap theory, because our study is basically on urban development and urban dynamics in Lebanon, and mainly in Beirut, in the capital city of Lebanon. All right, so, and the reason why this was important is because we managed to get grant from the European Union and from the Research University Board, and we were actually approached by the EU Development Agency to do some consulting on how can we examine the urban or housing sector in light of a huge influx of refugees into the city in the light of the Syrian war in 2011. So that basically was the main motivation there. So what we, and I will walk you through the challenges that we faced while we were doing this research, and mainly it's data challenge, because data wasn't really available as we wished. So I will show you what we did in order to collect the data and how we make use of econometrics modeling in order to fill some gaps. So we assume that, basically in our model, household is the agent. And these agents or these households live in different locations. So these are dwellings mostly. This area is overly populated, and it is somehow complicated because it's not very much homogeneous across section. So there is some divides or segregation across some sectarian or religious lines, because people would like to live with in quarters where like-minded people live there. We call this somehow cognitive dissonance, when you are not very much comfortable with your neighbors. So what would be the propensity to move, or to change residence? So we took this kind of like cultural and political factors into consideration when we run the simulation. Let me first make some definitions here so we are on the same page when we talk about agent-based model. And maybe some of you in the room are in fact more experienced with agent-based models than myself. In fact, I credit my co-author for developing that part, because I am mostly behind the econometrics rather than the simulation. So agent, as defined by some authors, is a representation of a decision-making entity in the real world, right? It can be an individual or an organization. In fact, for those of you who are economists, this basically is in line with what economics also define agents, right? So it can be a government or a household or an individual or a company. So agent-based modeling is a paradigm for simulating the actions and interactions of autonomous or heterogeneous agents, which do not need to be perfectly rational or perfectly informed. And that is what I like about using ABM models, actually. Unlike in economics, we assume rationality in most of our models. In this case, that is, to me, more pragmatic, more practical, rather than injecting rationality in your model. Here, you watch your agents and you see how they react, within a certain environment over time, of course. So these models are constructed to discover possible emergent properties from a bottom-up perspective, as I just explained. So we look at the movement of these agents, and they attempt to replicate in silico or in a digital way certain concepts, actions, relations, or mechanisms that are proposed to exist in the real world in order to see what happens. So basically, we're asking the question, what if? And this is how ABM models are important, because they answer this question, what if these parameters change, what will happen? All right, so in the literature, people have used ABM models in different contexts that are similar to ours. So mainly used in housing market, like search behavior in China, for example, it has been used. And also to examine refugees, like in Africa, conflicts in Africa, conflict in Syria. So there's at least a couple of papers, and also migration into Europe. So we are in this line of research, we are using ABM to model the influx of migration from a neighboring war-torn country like Syria to a small neighbor country like Lebanon. So how this kind of like migration of refugees would impact the housing market in the capital city. Why Lebanon? Well, certainly it is very complicated at the geopolitical level. Beirut specifically has experienced an exceptionally high number of refugees. It's estimated to be 50% of Lebanon's population. So the whole country's population is around, according to some estimates, 5 million. Refugees have reached a level of 2 million fleeing from Syria to Lebanon in 2011, 2012, 2013, up until 2015. So certainly there was a huge toll on the infrastructure of the country, and on the dwellings, on the housing market. So we are focusing mainly on the housing market. Of course, this part of this work was done prior to the financial crisis and the economic crisis that Lebanon has, experienced 2 years ago, and still suffering from the impact of this crisis up to date. But that's why we expanded this work to examine what happened after the economic crisis of 2019. So there are these compelling reasons that makes the study of this specific geographical area unique and informative. The economy in Lebanon is neo-liberal. There are no, government, intervention in the public housing sector. Mostly, it's managed by the private sector. It's a laissez-faire kind of economic policy, though there is high dependency on imports in this economy. All right, so this is a picture that I've taken when I was in Beirut a few weeks ago. This is from a town that is 30 minutes on the top of the mountain that overlooks Beirut. And if you see right beneath the sun, that's the port where, or actually the whole Beirut city where the study is being conducted. And last year, August of 2020, there was a huge explosion that ravaged the whole city, in fact, and still the port is mostly destroyed up to this point. All right, so this is exactly the area we're focusing on. We wanted to examine what happened, what happens when this influx of refugees come in. And if you see, that is the Mediterranean Sea, and this is the greater Beirut area. So you have Syria to the east and to the north. Beirut is so if you go back to my picture, actually, if you look at the Gulf in here, so this is exactly. This is exactly this area where the port is. And so Beirut is divided into 12 neighborhoods. So each neighborhood has different characteristics in terms of real estate prices, population density, building density, maintenance level, population, ethnic, like religious background. So it's really a mosaic, kind of like very exotic place to live in. All right, so now we wanted to examine or to use ABM models, but we faced with the challenge of lack of data. And probably this is the case in maybe most developing countries. So we try in this research to bridge the gaps and to come up with models that will help us collect data well first, or maybe model the data so that we can use the like the results in our simulation. So luckily we had enough money to hire like almost 10 students as assistants. And we built a questionnaire and we asked these students to survey buildings, literally. So they went on to the streets and they surveyed around 1,500 buildings distributed on all these 12 neighborhoods or districts. So we collected the primary data on the housing quality, housing prices, maintenance level of the properties, and the population density in each district. But one of the challenges is to like we needed a housing price index. We needed to know how we measure, like what is the historical kind of like trend of housing prices in this area, in Beirut specifically, and more particularly in these 12 districts or 12 neighborhoods. So that was one challenge, and the government of Lebanon doesn't really manage to have such an index in place. I mean, they haven't done this before. Like if you look, for example, at this is not uncommon when you look at different economies. Not necessarily every single economy has its own housing price index. Actually, this is something usually that is conducted by private initiatives, like maybe your institute or other institutes or research institutes. For example, the case in the US is a case in point. This started by Robert Schiller, and like the Robert Shiller and Case, they started their Case-Shiller index back in the 70s until, maybe 15 years ago, it was acquired by, I think, Standard & Poor's, and now it is an official index, right? So that index is important. I mean, the same way we have CPI or consumer price index in place, and we keep updating it every month or every quarter, I think housing price index is equally important, especially when we know that when we learn from the financial crisis that broke out in 2008, mostly it was mortgage crisis, and watching or monitoring housing prices in every economy is very important. So this wasn't available, and so one way to overcome this, we built kind of like a theoretical housing price index that is built on a reduced form model. So we assume that if the market is in equilibrium, we set like demand for housing as a function of income, price of housing, which I will come back to this because we don't have price for housing, and then interest rate. So we build this kind of like reduced form model hypothetically. Also, the supply of housing is a function of cost of construction or cost of housing, price, and again, interest rate. So in order to run this model, we have data on the quantity. Usually it's the housing permits that the government gives out. I'm looking at the watch. I need to rush a little bit here. So, but again, we needed data on price, and that was missing. But kind of like we used an instrumental variable here to model price as a proxy, and then we did a second stage regression to have a better measure of price. So what we had from the tax authorities, we were able to get data on how much they collect taxes when people buy houses, right? So let's say it's 5% capital gain or capital gain tax. So we collected data on this, and from that data, it's a monetary value. So we had a projection on how much money that was spent on housing, and also dividing this by the housing permits that were given by the data. So we had an approximation of how housing prices were moving from one period to another period. So that was an approximation. In fact, we cross-examined this with the data we collected on the ground also. So again, it is really difficult to keep track of the same property unit over time, because that's the best way to measure how prices of real estate or housing price move over time, right? Is to track the same property over time, how the price is moving. So the data we collected does not necessarily track the same price over time. So one time we had a price for land, one time we had price for an apartment, and one time it's a house. So we also managed to have an average price over time, and then we use this as a cross-examination with the regression model that we did. So again, we took this kind of like supply-demand model. We had a second stage where we ran the price over income, cost, and interest rate. Again, we devised an equation for price and equation for quantity, but also it was very stretched kind of like assumption that we assumed that the economy is at equilibrium all the time, so we needed to allow for partial adjustment. So what if they were not equal all the time? And in fact, this is the case. It is hardly that supply and demand are equal in the housing market. there is always, a gap between supply and demand. So we allowed for some partial adjustment, like, if we assume, quantity now is less, or quantity maybe demand is more than supply, or supply is more than demand. And we allow for this partial adjustment to re-estimate the model again when we introduce the partial adjustment. So to make a long story short, I'm not reporting here the results of the regressions, but we learned from the most important part was to calculate the elasticities from these models. And in fact, we validated this, they are very much aligned with real data. So for example, let me give you an example. So income elasticity is almost 1. So for 1% increase in income, you expect the price to increase also by 1%. So it's almost 1 to 1. In fact, recently when I was in Lebanon and in Beirut mostly, now given the economic crisis, there is a drop the drop in income is 50%, because if some of you are familiar with the economic collapse that has been, going on there, the currency has lost 80% of its value. And, because you don't rely 100% on imports, so people have not really lost 80% of their wages. You can say it's around 50% of the wage, because some of the goods and services are produced locally. And but there is a shortage of foreign reserves, huge shortage of foreign reserves. So now, for example, in downtown Beirut, an average price of a, let's say, medium-sized apartment, let's say 3-bedroom apartment, used to be $1 million. Like now this might be like mind-blowing for some people who are not familiar with this market. Yes, this market is really very kind of like high-end market, as if you're buying a small, place in Beverly Hills. So you pay $1 million to buy an apartment in a city like Beirut, like maybe similar to Dubai prices, for example. But now, if you have cash, in fact, what used to be $1 million value, you can pay now $500,000 to acquire the same place. So we see a drop like of almost 50% in value, which exactly is aligned with the drop in income. So that is kind of like not really a bad estimates that we got from our model. So also, I will not go into the details of the parameters of the simulation, because you can see this in more details in the paper. I'm more interested in jumping to the new version or the extension of the model. So here in this ABM model, you need to assume the rent gap. And here I wanted just to explain quickly how we use the rent gap theory. So the rent gap theory basically is a theory that helps us predict the urban development in any geographical area. So it is based on the premise that if the difference between the current return on any property and the potential return, if you replace the property with something new, if that gap is big, then you predict that this property should be demolished, right? For example, let me give you, like suppose in downtown Moscow, there is a 3-story building that is very old. So if you are the owner of the building, probably you make, let's say, 1,000 euro or $1,000 on a month on this property from rental return, right? However, if you demolish the building and you build a high-rise building or a hotel, then your monthly income would be, let's say, $50,000. So the bigger the gap between the existing return and the potential return, the higher the possibility that this property will be demolished. And that rent gap theory gives us kind of like a pathway to predict how the urban development in a geographical area will be reshaped in the future. So if we have information for these elements, so that's exactly what we fed our simulation to study the urban development in Beirut, given the influx of refugees. So I want to run very quickly now because I have only a few minutes left. So at the location level, we had maintenance data or data on maintenance of the property, value. We have the value gap, which is, like I just explained, distance from the city center, which is the highest, the most expensive, and how, if the property was empty and for how long, or if the property is occupied. So we had all this data. At the agent level or the household, the mobility propensity, like if the household is happy where they live, or they wish to move to a different quarter, for example. We have also a parameter on the culture. Again, like we took into consideration the ethnic or the religious divide across different segments of the society. We studied income level, or we introduced income level into the data. Cognitive dissonance, as I explained, people sometimes are not very much happy with where they are. And also the time spent in the location, and you will see. All right, so this is perhaps this is the area that we studied. So that is the simulation. This is the actual. So you can see, like, for example, red indicates increase in mean price between 2009 and 2015, which was exactly the case. Green indicates stable prices. Blue indicates decreased price. In fact, this blue here in this like picture to the left, this is like the entire Beirut city that we studied. This is where the port is located, and this is where the explosion took place last year. So our simulation predicted that the prices will go down. In fact, like, it's not a prophecy, but based on the simulation, this area was not really maintained very well, and we predicted that the prices will go down. In fact, the prices are lower nowadays. I don't want also to delve into the much details, but mostly it's about to inform inform ourselves about, like, what can we do with these simulations. So as you can see, the iterations, the time, like, for example, when you replicate time 600 times, if it's monthly data, for example, this is like 50 years later, what will happen? And you will see the neighborhood here, where to predict the slum to be located. Slum being almost inhabitable, like very overly populated. Maintenance level are at the lowest, standards. Probably the quality of housing is very, very low, and so on. So that is the product of a simulation where with different iterations of time, if we assume no refugees, and we assume a certain level of capital being the investment that is willing to be put in for regeneration, to rebuild. Like in rent gap theory, for example, you would see that you predict that a certain neighborhood will be rebuilt because the rent gap is really wide. But what if you don't have the capital to rebuild? So that begs another question. So we fixed the capital amount, and we came up with the predictions of how the neighborhoods will evolve over time. So now this scenario was without refugees. Now, what if you introduce refugees? Then you have a completely different, dynamics. So, and again, we have time iterations here. You can see slum locations are in dark blue. You probably are not very clear, but so you see with refugees, you expect more slum locations. Uninhabitable locations are less now, because with refugees, every single area in the city will be exploited in many ways. So the expectations were that like uninhabitable locations are now less than without refugees. Here and that is actually was part of the policy recommendations that we did, because basically this was a consulting report before we moved the work into a publishable scholarly work. What if there is no intervention? What will happen? What if you do regeneration? And what if there is a slum improvement? So slum improvement, when the government intervenes just to improve the housing conditions. Regeneration is when you demolish and you build from scratch. And if you don't intervene, so we see that again, the dark are the inhabitable, regeneration, and slum. So if you look at the data, with the percentage of slums, in fact, will drop when you do regeneration, but will not really drop much if you do slum improvements. So this was one of the recommendations that we made. Ironically, also one of the interesting findings is that with no refugees, the percentage of slums is higher with refugees. So again, that was very intriguing to us to understand why is it the case. And it seems that over the longer term iterations, refugees might blend in and might contribute to the economic activities in a way, and then they might help turning slums into better locations to live in. So that's probably why with more refugees, the percent of slums was reduced from, let's say, 41% to 27%. All right, so we did an extension, and this is one last remark I would like to make, just to not to exceed the time allowed for me. In fact, we were inspired by the EU commissions that what if you expand the data, expand the geographical area? Because imagine in the previous study, we were looking at only this area here. So now what we did, we expanded the model to go 20 kilometers in each direction, right? So to allow for urban development. People would live in, now we're monitoring what happens when people are, let's say, allowed to move to the suburbs. So we moved like 20 kilometers north, south, and east. And now we're actually studying the greater Beirut area, which is Beirut and its vicinities, not only Beirut. And so again, we work on the visualization, what we expect and so on. But what I want to share with you, something that is very, very interesting. We studied actually 223 towns or villages or districts, if you like. Okay, so if you go back to this, to the graph or to the picture. So these are 223 localities. And the challenge was how to look up the population over time. So so you might look at GIS data and come up with the population in each data point, but then we needed, to look at this over time, and that is, to my surprise, that is also a GIS data. So you can look at what was the population in 1990, and at different points in time, in every single locality. But the challenge was, if you take the GIS data, it's the coordinates, right? It's X and Y. And now if you determine, let's say, if you take a town X, which has a certain coordinate, now we needed to match this coordinate with the GIS data, or what is the most proximity population to this coordinate. And that was actually a challenge. And we solved this using Stata by matching GIS to these 223 localities that we want. And in fact, you can do the matching by also taking the five proxies or the five nearby localities to your village or to your specific locality. So this was kind of like an interesting exercise to do. And we were able to collect population data over time for each single locality. and we fed this into the simulation model that we used before. So just to run very quickly, this was a very interesting exercise to do. And here is the expansion. And you can see that, and in this case, we studied 3 different kind of like historical events. 2005, 2006, there was a war with Israel. 2011, the Syrian war, and 2020, the economic collapse and the port explosion. So we examined these 3 events, and in each event, we studied how housing market was expected to change, given our simulations. So we kind of like we ran the model to predict this. Yeah, so we had a simulation where what if there is no explosion? What will happen? So, so this is like 6 months after the explosion to the left. 6 months if there is no explosion, and you can see, like in uninhabitable area in the red here, while there is no such thing if there is no explosion, and other dynamics that we examined in the paper. So yeah, so these are kind of like expansions. I think I will stop it here. I mainly meant to share with you the challenges, data challenges, and also how ABM models can be employed in geographical areas to make predictions and policy recommendations. A third thing actually is how we use GIS data to feed in our simulation. So yeah, thank you very much for your time. I think I will stop it and